Scientific consensus is the collective agreement among scientists in a particular field, based on extensive evidence and analysis. It's not about unanimous opinion or popularity, but rather the convergence of findings from multiple independent studies that point to the same conclusion. Think of it as the scientific community's best understanding of a phenomenon at a given time, based on the evidence available. To understand why consensus is important, we need to revisit the foundation of science, the scientific method. This process begins with observations and questions, leading to hypotheses that are tested through experiments and studies. When these experiments are repeated by different scientists in different settings and with consistent results, the findings gain credibility. Consensus arises not from a single study, but from the weight of evidence accumulated through rigorous testing, replication, and peer review. This is what makes scientific consensus a hallmark of reliability. It's the result of years, sometimes several decades, of scrutiny and refinement. A great example of scientific consensus is the theory of evolution. Over 150 years of research across genetics, paleontology, and molecular biology have confirmed the mechanisms by which species change over time. While there are debates about specific details, the broader framework is overwhelmingly supported by evidence. Another example is the germ theory of disease. It may seem obvious now, but the idea that microorganisms cause illness was once revolutionary. Thanks to the work of scientists like Louis Pasteur and Robert Koch and subsequent research, the scientific community united behind this theory, transforming medicine and public health. We now know that viruses cause diseases such as influenza and COVID-19, that bacteria can cause serious infection resulting in sepsis, meningitis, or tuberculosis, for example, and that parasites can give rise to debilitating and life-threatening disease such as malaria. One of the most impactful examples of scientific consensus is vaccines. Decades of research by immunologists, epidemiologists, and public health experts have confirmed that vaccines are safe and effective in preventing diseases like measles, polio, and influenza. The overwhelming evidence supports their ability to save millions of lives and reduce the burden of infectious diseases. While minor side effects can occur, the consensus remains clear. The benefits of vaccines far outweigh the risks. This understanding has shaped public health policies and vaccination programs worldwide. More recently, we see consensus in areas like climate change. Decades of data from atmospheric measurements, ice cores, and climate models all point to human activities as a major driver of global warming. This consensus doesn't mean there's no uncertainty or ongoing research, but it highlights the robust agreement on the fundamentals. Scientific consensus serves as a guide for decision-making. It allows policymakers, educators, and the public to act on the best available knowledge. For example, the consensus on the link between smoking and lung cancer prompted public health campaigns and policy changes that saved countless lives. It also provides a framework for trust. While individual studies can have errors or outliers, consensus reflects the collective scrutiny of the scientific community. By leaning on this collective understanding, we reduce the risk of being misled by misinformation or isolated claims. Some people misunderstand consensus as a sign of dogma or groupthink, but it's quite the opposite. Scientific consensus is always provisional, meaning it's open to being revised or overturned with new evidence. History offers examples like the shift from Newtonian physics to Einstein's theory of relativity, where new evidence reshaped the consensus. Another challenge is the misrepresentation of consensus. Fringe views are sometimes amplified to appear equally valid, creating a false sense of debate. This is why it's crucial to distinguish between genuine scientific disagreement, which drives progress, and manufactured controversy, which undermines public understanding. Vaccines, for instance, are sometimes the subject of misinformation campaigns. Isolated or fraudulent studies can sow doubt, but the overwhelming consensus, built on decades of rigorous research and real-world data, remains steadfast in supporting their safety and efficacy. This highlights the importance of distinguishing between genuine scientific disagreement, which drives progress, and manufactured controversy, which undermines public understanding. Denialism and skepticism might seem similar on the surface. They both involve questioning claims or ideas, but they are fundamentally different in their intent, methods, and impact. While skepticism is a cornerstone of scientific inquiry, denialism undermines progress and can be profoundly dangerous. Skepticism is a healthy and essential part of the scientific process. It involves critically examining claims, demanding evidence, and testing ideas through observation, experimentation, and logic. Genuine skepticism is open-minded and willing to change when presented with strong evidence. For example, skepticism has led to breakthroughs in understanding diseases, improving technology, and refining theories. Scientists questioned the geocentric model of the universe and replaced it with the heliocentric model through evidence and analysis. This kind of questioning moves knowledge forward. Denialism, on the other hand, rejects established evidence and consensus without a legitimate basis. It often employs fallacies, misrepresentation, and emotional appeals to dismiss scientific conclusions. Unlike skepticism, denialism is closed-minded and resistant to changing its stance, even when confronted with overwhelming evidence. Denialism poses significant risks because it often influences public opinion and policy, leading to real-world harm. For example, denialism undermines public health. Vaccine denialism has led to preventable outbreaks of diseases like measles and polio. It delays action on critical issues. For instance, climate change denial has delayed global efforts to reduce greenhouse gas emissions. By spreading doubt about the science, denialists have hindered policies aimed at mitigating environmental damage, making the crisis worse. Denialism often involves attacking the credibility of scientists, institutions, and peer-reviewed research. This erodes public trust in science and fosters suspicion, making it harder to address pressing issues like pandemics, environmental degradation, or technological advancements. Skepticism and denialism may appear similar, but their differences couldn't be more profound. Skepticism drives progress, encouraging us to seek truth and improve our understanding of the world. Denialism, on the other hand, is a rejection of evidence and reason, often with dire consequences. Scientific consensus is not perfect, nor is it immune to revision, but it represents our best attempt to understand the natural world. It's a testament to the scientific method, a process built on evidence, collaboration, and self-correction. By appreciating the importance of consensus, we can make better decisions for ourselves and our society, grounded in knowledge rather than speculation. So, the next time you hear about a scientific consensus, remember, it's not just an opinion. It's the result of a rigorous process that helps us navigate the complexities of our world.